Before we begin, we would like to thank the National Science Foundation Office of Polar Programs for their financial support to ARCIS and this seminar series. Next slide, please. Now I'd like to introduce our speaker. Since 1978, Denver Holt's research has been on owls and their ecology. He has published over 100 papers and technical documents, including 4 species accounts for the Birds of North America project. He was team leader for the Strigea family owl species accounts for the Handbook of Birds of the World, Volume 5, which covered 189 species of the world's owls. In collaboration with elementary school teachers, he has co-authored 2 children's science books on owls, Owls, Who Are They? And Snowy Owls, Who Are They? In 2006, he was a chapter author on owls for the book Arctic Wings, highlighting the birds of the Arctic National Wildlife Refuge, Alaska. The foreword was written by former United States President Jimmy Carter. In the year 2000, he was named Montana's Wildlife Biologist of the Year by the Wildlife Society of North America. Holt's research was the cover story for the National Geographic magazine in December 2002. His work has been subject of television bites on ABC, CBS, NBC, CNN, and Disney. His owl research has also been featured on Audubon's Up Close series, PBS's Birdwatch, and David Attenborough's Life of Birds, among others. His research on snowy owls has been showcased in documentaries for National Geographic Explorer, NHK Natural History Unit of Japan, and the Norwegian Broadcasting Company Natural History Unit. His snowy owl research was also featured in the British Broadcasting Company's documentary series, Frozen Earth, a sequel to the Planet Earth series. In May 2011, Holt's research was featured in the New York Times. In 2011, Holt also advised and worked in the field with the PBS documentary team filming The Magic of the Snowy Owl at his research site in Utqiaġvik, Alaska. In 2012, he was inducted into the World Owl Hall of Fame. In 2021, Hakai magazine featured Holt's 30 years of research on snowy owls, and in 2022, he gave his first TED Talk. When not researching owls, Holt is involved in wildlife watching tourism as a natural history tour guide and is co-owner of the Wild Planet Nature Tours. He also guides private nature history tours and is a part-time trip leader for Victor Emmanuel Nature Tour Company, one of the largest nature tour companies in the world. Please help me in welcoming our speaker, Denver Holt. Denver Holt, at this point, I'll turn the presentation over to you.
All right, so now I go to share screen?
Yes, exactly.
Okay, yes, this, and then I go to this, I think, share, and let me go to the beginning. Okay, first of all, sorry about having all that stuff. My office puts it together, and you know, it's just a bunch of whatever. So
it's good background.
Sorry you had to read all that.
No, that was great.
So,
great background. I'm
I
going to mute myself and let you go.
Okay, so I guess I'm on. All right, whoever's joining here, thanks very much. Wasn't exactly sure how to go about this, mix between, some nice photos and, nice natural history stuff and a little bit of research as well. So I'm going to try to do that. As you can see, it's been a long time there studying the owls. I finished my 30th year last year, coming up at 31. And, I know you guys all know where this is, but there's Barrow. But I think the point to remember here is it just, in Alaska, we really have only a small percentage of the world's, tundra, most of it in, Russia and Canada, a little bit in the Scandinavian countries, et cetera. So that's where we are. And this is Barrow in July, just to give you an idea. It's kind of a cold place, actually, most of the time. Weather is harsh, even in the summertime, the brief summertime. But then that kind of gives you an idea of it, moist, cool, and short summer. And this is just very quickly, it's 30 years of breeding study, 30 years of lemming trapping. It's 100 square miles or 214 square kilometers as a study area, and I've 284 nests found, 800 snowy owls, banded, mostly chicks, 43,000 prey from pellets, 3,300 prey cachette nests. The first snowy owls in the world with satellite transmitters we found in 99 and 2000, I think there were 6 of them. The first live cameras on snowy owls ever, and I think the only one still, and we'll hopefully have another one this year. And then the snowy owls, without a doubt, the avian icon of Arctic conservation. So just a few things to, kind of keep in your mind as we go through this. And, snowy owl in the nupia culture. So Barrow or Utqiaġvik, a place to hunt snowy owls. So the Inupiats there and the snowy owl have had a long history, dates back 4,000 years. And it's one of the few species, that they carve. It's not necessarily a subsistence animal, even though they do eat them from time to time in the summer. It's, it's not, like whales or caribou or fish or things like that. So they have quite an admiration for snowy owls as a summer food source to a point, eggs, as a food source to a point, and then taking chicks from nests as pets. And this is just, an ivory carving right here, give you an idea of their appreciation for it. This is what snowy owls kind of encounter when they come back to the breeding grounds in Barrow, and let's just say late April into early May, usually laying eggs by about early May. So these tall mounds here, which we'll see later, usually receive less snow, kind of windswept, and melt off before the rest of the tundra. When we go out and about, just some ideas on how we find them. What we do is we scan just for adult white males sitting on mounds or ridges. That's the key to finding them, is number one, adult. So they have to be pretty much, fluorescent white. And then once you find them, then you scan left to right of them because they're usually on territories. And, you might get lucky and see female chasing the males, an indication that there's an active nest somewhere. And really what we're after is this scene here is to, find that adult male in a vertical posture, then scan left and right of that male to find the horizontal white thing out there. And if it's not a plastic bag or a piece of styrofoam, it can be a female on a nest. That's one of the ways we do it. It's interesting that the male owls are always within about 500 meters either side of the nest. And they might venture out further than that, but they're always very close to nest because they do nest protection. Just gives you an idea now. This is like 277 nests. This is our study area again, 100 square miles roughly. And it shows you the distribution of the nests over the years. It tends to be a little more coastal. If you look down from the top down to the bottom there, you'll see, do I have a pointer? Can you see that? And it kind of tends to be a little bit more coastal and less inland, but it's a big area to cover, difficult to find it. So anyway, this is kind of interesting stuff here. I just want to give you just a couple tidbits here. That average nest distance over 18 seasons is, 1,600 meters or 1,100 meters roughly. In the high density years, the average is, just over 1,000 meters. In the lowest density years, it could be, 3,000 meters. But what was really interesting when we looked at this annually, the nests are definitely randomly distributed. But when we looked at it collectively now over the 18 breeding seasons, and this represents 277 nests, clearly is a significant clumping going on. And so what it appears, two things jump out. One is it's the higher, drier sites. And the other things too, that's where the highest densities of lemmings are. So if you want to know where lemmings are, just look for the snowy owls. It's very, very simple. And so if you're doing sampling, and you're not in areas where the owls are, it may be a little misleading on the density of lemmings per unit area. So anyway, we know females incubate and brood, enormous brood patch. There's increases in estrogen and prolactin, the feathers fall out, so you can apply heat directly to the eggs there, but enormous brood patches. It's kind of interesting compared to other birds, how big it is. On our study area, clutches will run from 3 to 10. Most 3-egg clutches fail. 4 can go either direction. When you start getting 5 and above, they're going to make it. Although some chicks might die, but at least they're going to have some breeding success for the season. So, we've been doing this over the years, taking measurement data and compare that with the eggs. Interestingly, that I found out, a lot of birds are supposed to hatch on the top end of the egg, but all snowy owls hatch from the side of the eggs. And that was something I learned just very on in the study. And then asynchronous hatching, as you know, in most owl species. So we can have, a chick that's 1 day old or just hatching out, and a chick that's almost 2 weeks old, depending on the hatching intervals in the same nest. All right, and then, the neoprol down, the first down or the prototyl down, if you want, is white, eyes closed, can't thermoregulate that time, totally dependent on the female for thermoregulation, food, and protection. Growth is fairly rapid. By about the first week, the second down, the mesopyle down starts to come in. And towards that 10-day period, so the eyes will start to open, maintaining the egg to for a variable amount of time. Super fast growth rates here. They're all in the mesotile down there, pushing anywhere from 10 days to 2 weeks old in this photo here. And again, now they're getting up. The oldest one here is probably 15 plus days old. So very, very fast growth. And what we have done over the years is just, monitor the chicks, monitor the growth, monitor the plumage development. It gives you an idea of just some of the work we're doing. This is some of the growth rate stuff we did. And you can see all the points here, and you see the line through it. Most of the growth, I don't know if you can see here, but really right before they leave the nest. So they leave the nest at about 3 weeks of age on foot, and that's when they put on most of the body mass, and that kind of tapers up to the top here. And then it's harder to find them and get more data to record. And then once they fledge, we don't know. So we can bring them up to about fledging weight. And this is just another look at it in 2 years of data. I wish we had done this for more years. 2 years isn't really much data, but it shows you that in both years with decent sample sizes, they pretty much grew at about the same rate. Another thing that we're interested in is flushing distance. No other owl in the world that I know of, about 268 species of owls in the world, flushes from their nest when potential danger is way, way out in the distance. And the snowy owl is the only species I know that does this. Most everyone else tries to hide, but look at the habitat here. It's wide open, it's brown and green, it's a big white owl, there's no vegetation high end. So what they'll do is the first line of nest defense is they flush from the nest. You got to look at this here though. Down there on that left foot, you can see a band. We weren't able to read it. I've heard people say that snowy owls don't ever return to the same area. Well, in our area, some do. All right, but anyway, they flush from the nest. And this gives you an idea of approaching danger, which is researchers. And so we try to measure this here. And this is just 1 year data. We have a lot more years, but just to show you the average distance in this year was about 400 meters. So when they see danger approaching from about 400 meters off, they'll flush from the nest. If the danger is going straight heading to the nest. If you walk sideways, things vary a little bit, they're a little calmer, but they know when you're walking right to them. All right, then some of the other things we're interested in is once you approach the nest. So the first sign of nest defense is to flush and go sit around and make pretend you're just hanging out and there's no nest. But of course, we know that. Then if you start to get to the nest, the female may come in and fly in and look at you and spread her wings out and maybe give a little aggressive maneuvers or scream at you. The male rarely does this type of behavior, but males will often come in and they'll hoot above you, fly, attack, etc. But rarely will they do this female type behavior where they'll come in and try to distract you or threaten you. Females scream, males hoot, and then the ultimate in nest defense is attacks. This is predominantly conducted by males. And so this is what it looks like during an attack. And it's usually directed at us because we're disturbing them during our research at the nest. This is coming in here. This poor guy was a plant ecologist here, and his brand new Patagonia coat got ripped open. You can see the chick to the right of his butt right there. All right, and so this is again what it looks like. It's pretty aggressive. To us, it's exciting. To them, it's serious. And someone brought their dog out one day. This owl flew 500 meters across the tundra. So imagine what they can do to Arctic fox when they come in after, which they don't like canids at all. All right, and so this is just, this is just a frequency chart here. And so there's things that we need to pull out of it, to analyze it. But I just wanted to show you that both males and females bark. Males hoot, females rarely do. Females scream, males rarely do. Both attack, but it's dominated by males. Females display and rarely do males display. So it's kind of interesting separation of behaviors during nest defense and other duties as well. I kind of like the system myself. So then we were trying to look at nest defense behaviors in relation to how many young fledge. And so this was a graduate student project. And again, short term, so there's not a lot you can say out of it, but it was a suggestion that the more aggressive pairs fledge more young than the less aggressive pairs, which I thought was kind of neat. But once again, you only have 2 seasons of study and you really need 10 seasons. Some of the other things that we've been looking at over the years is why leave the nest at 3 weeks of age. So I might have implied that already. So the young are in the nest, they develop fairly quickly. By about 3 weeks of age, they leave the nest on foot, generally in order which they were laid or their age. And so, what's the purpose of that? Is there stress in the nest? Is there sibling rivalry? Is there some other reason to leave the nest? Well, it's interesting that always the oldest leave the nest first. So and we never see sibling rivalry. So that, kind of rules that out in the fact that, if a big chick was picking on a small chick, you might expect the small chick to leave the nest, but it's always the biggest chicks and generally in that order. So anyway, all right, we were interested if they were stressed out working with one of my partners at Tufts University. We decided we would look at corticosteroids. And, it's tough to do because there's some developmental processes there. But make a long story short here, when they leave the nest, whether they're on the nest or they're dispersed out in the field, their court levels are basically the same. So it appears, except for maybe like an individual that's sick, that when they leave the nest, they're not stressed out at all. It's just time to leave the nest. Most likely it's because they nest on the ground and there are mammalian predators there. There's polar bears around the coastal areas. There's Arctic fox. Sometimes they might get a chick, but most times not. The owls are tough on them. But depending where you are, there could be wolverines, there could be, wolves, other foxes, etc. So we just think it's because they nest on the ground, but they have to stay there up to 3 weeks of age because of the developmental process. We're short at all these on the ground at 2 weeks of age. So anyway, they're really calm, cool when they leave the nest, and looking pretty good at this age. All right, so we continue to monitor them, and we're trying to figure out reasons why they die, because some do die, and we're not, as much as you like them. I mean, you really got a lot of passion for these guys, but when it's not our job to help them if they're sick, it's our job to try to monitor why they might die, and so some die and some live, and so anyway, most of the time we can attribute it to starvation. The younger chicks, especially in low lemming years, they just get outcompeted. As I said earlier, we don't see that sibling rivalry that you might see in eagles, the more primitive animals like that. We don't see that. We don't see favoritism by the females. We see them apportioning prey relatively equally, and even kind of moving in a direction of taking a little bit more care of one that's lagging behind than the others that would well. But basically, they just get outcompeted for food. Occasionally, however, with severe weather, 3 heavy days of rain is what we think can cause high mortalities for chicks that you wouldn't think would die. And I think that lemming populations, this is just, kind of guess, but the lemmings aren't as active in that heavy rain. It's a lot harder to hunt. So when we find these dead chicks, it looks like that they've, got pneumonias, all the fat around the heart, stuff like that seems to be absorbed. So it looks like that because of that, they're susceptible to other things and hypothermia, et cetera, and they do end up dying. Some live, however, and so you just continue to monitor. And one of the things we noticed in that 30-day age, roughly, was, if you can see this, the light colored one, you have a plumage here that's down, this mesoptile down tends to be silver gray, and the mesoptile down on the other one here tends to be sooty gray. And so we thought, oh, heck, is this can we tell the difference in the sex at this stage? And we also noticed, this will hold true right up until fledging or getting ready to fledge. And just before they fledge, we capture all the birds, and these birds are, they're siblings. And the one on the left, the dark one, we would predict as a female. The one over here predict as a male. So what we did is we took a composite feather. We identified, a number of the flight feathers, and we found that you have transverse bars up here, you have irregular bars down here, and you have kind of spots, let's say, over here. And so, long story short, if you have a bar, an irregular or transverse bar, and it touches the rachis or the feather shaft, it's a female. If it doesn't touch it, it's a male, and you can see it. And we built this model here with help from a statistician, and you can look at your secondary number 4 and predict with great accuracy if it's a male or female. So people have been doing that now. What we did is we took blood. We got them all right. Okay, so we took blood. I think it was 146 or so chicks that we did this with, and then we sent them in. And we didn't tell the analysts what they were. And so we left it to the side here, and we got all 146 correct, and then they built this model. So people use it now, and seems to be a pretty good method for identifying first-year birds. some of the other things, it's interesting with measuring nest mounts here. And the Inupiat friends up there, they tell us they think we're dumb. Everybody knows that snowy owls nest on high mounds that are windswept and get less snow, and other things that we do and measure that they kind of laugh at. You white guys are always counting things, they say to me, even though they're my friends. So anyway, you do that, and sure enough, you get used and unused sites. And long story short, the nest mounds are twice as high as a random set of mounds, and it's just kind of exactly what the Inupiats told us. And that goes for a lot of things they tell us. So anyway, capturing them, we don't capture as many adults because once the breeding season's on, it's so much effort. It's 100 square miles to cover, and you're hiking every single day. I lose 8 to 10 pounds every year. We rarely get a repeat student the next year because it's such a brutal project. But anyway, so the first satellite transmitters put on an owl in the world, but probably in a snowy owl for sure, were the 6 we put on way back in 99 and 90. And that just shows you what they're like. Now the technology is better and everybody's doing it, so we're getting a lot of interesting information. But this is what they did. And so I just want to show you here from Barrow, they went out into the Bering, they went over Russia, they went up along the coast, they made some interesting stuff. Then they came back over here, back through Barrow up to Victoria Banks Islands, Canada. And that was really cool for us, I thought. But then, of course, if you read the historical literature, which no one does, you find out that people have known this for a long, long time, that snowy owls will spend the winters in the Arctic. They'll be near plinias, they'll be near open leads, they'll be near bays where it's opened up, and presumably they eat, seabirds and sea ducks and things of that sort that also winter in those areas. Occasionally they stay in their breeding grounds, but not that often. So where we thought it was really cool stuff, once you read the literature, you find out, yeah, people have known this for a long time, and the Inupiats have known it before everybody. So what do they eat? They eat everything in the Barrow region. They eat ptarmigan, they eat pintails, they eat eiders, they eat longspurs, they eat shorebirds, and they eat lemmings. So just to give you an idea of those 43,000 or whatever it was, 43,000 plus prey from pellets and the 3,000 plus from nests. The favorite bird seems to be the red phalarope here. That seems to be, even though it's a small percentage. This was a really neat one here. This is a male spectacled eider that the female came off the nest and went and killed. And she struggled coming back to the nest. She had to catch some air coming off the mounds in order to glide back into the nest, but she fed on it for 2 days there with her chicks. Wide range of food, everything up there they eat. Both species of weasels, even some of the large, gulls, glaucous gulls, etc. And then occasionally, a chick will die in the nest. And again, as I told you, we never see any kind of sibling rivalry where one kills the other, or even beats up on it. They seem to be pretty cool and calm with each other. But occasionally a chick dies, again, probably from starvation. And it just varies, I guess, among females or how hungry they are. Sometimes she'll eat them, sometimes she'll eat them to starving chicks, and then other times they just lay there. So I don't really know all the answers behind those decisions. 2 species of lemmings occur in the area. We all know about lemmings and owls, snowy owls. The collared lemming dicrostonix, the brown lemming lemmis. And so this is basically what we do from pellet analysis. It goes from lemming to pellet to dissection. And so here you go. So 43,689 prey. I imagine it's the largest sample in the world. If you look at pellet analysis, 99% of what they eat during the breeding season is the brown lemming. And that's what it looks like. Make the students do all this. And then if we look, I don't know if you can see the top, there's 3,334 prey cachet nests. This is really kind of cool here now. So our species diversity increases by reaching prey cachet nests. People would argue, well, your pellets are biased. You could argue that, but if you look at the sample size like we have here, still, when you look at caches at nests, so it increases to about 30 species of birds and mammals that they eat, it's still over 9% of the diet is brown lemmings. So it's all about brown lemmings for snowy owls in that region there. And this is what it looks like, at the nest here in a good lemming year. Males will bring in food. Females do a little honey, but not a lot. Males do pretty much all of it, while females sit there and scream for food and brood their chicks. So this is kind of neat too, is we get free data and it's provided by the owls of what they actually bring to the nest. So I told you about increasing the species diversity by identifying particularly birds, but now these lemmings, we get even more data, and we're able to look at sex, body mass, and reproductive status. It's really, really cool. And this is a nest. There was 55 or so here, but the highest we have found piled up in a nest, and this is piled up naturally, was 86 lemmings piled up in one nest. And these are all brown lemmings, you can see here. Because it's so cold, they don't rot that fast, but and some do, but they'll just eat them as they grow. They eat them faster than we can record them. So anyway, this is kind of cool too. Of the 30 years I've been there, they bred in 18 breeding seasons, although they're present every year. And this gives you the grand mean. So the average lemming that they're bringing back to the nest, okay, this is what the males, primarily males, are bringing to the nest, is 71 grams, and not a bad sample, 2,508. Right now, we also do our sampling of lemmings. We have a snap trap line we've been running for 30 years as well at one site, and then we added some others. And so then when we look at the grand mean of those that we snap trap, it's 48 grams with a decent sample, again, 2109. So it's kind of, and then we've done all the statistics and all the stuff. This is kind of interesting. So two things, kind of pop into your mind. One, is our sampling of lemmings really indicative of what's running around out there? Or two, are males being selective in only bringing home the biggest, fattest, heaviest lemmings to females that may need them to feed themselves and the young? We think it's the latter. And so anyway, this is what it looks like. We think it's the latter, what's going on. We're trying to support that. Now, if you look at the non-breeding season, the same thing is going on here. So in the 12 seasons where they were present, they didn't breed. You look at the grand mean, it's 53 grams. So I'm kind of thinking that males are being selective and bringing the heaviest ones into the nest. And there may be bigger lemmings in high lemming years than in low lemming years. And we're still analyzing that right now, but it's just kind of interesting things to think about. All right, and once again, so monitoring the lemmings over the years, counting their nests as well. And this just kind of shows you, our 3 trap lines. So our longest one goes from 92 to present. And then we started some other ones in, was it 97 and 98, I think. And you can see the number of nests and then the index of nests at each lemming trap site. So nests, and then the trap sites for the 3 areas are Nunavut and Mayoyak. And you can see it's a pretty close fit, just like everyone suggests. A lot of lemmings, a lot of owls, few lemmings, few owls. But you can see it kind of tails off down here. So somewhere in here, which I'm going to get to in a bit, an interesting event occurred. The Stellar's eider, which is a threatened species, purported numbers have declined, blah, blah. Their distribution is primarily Russia, but they have an overlap over there in Western Alaska, in particular in Barrow. So because of that decline, I don't think that there was evidence that the foxes, causing decline. But anyway, when they started killing foxes somewhere in this 2006, 7, 8 range, and we don't know for sure, but in my opinion, it messed the entire ecology of the tundra up. And it's interesting that things started changing then. And so anyway, we'll get back to that in a minute here, but I want to show you why that was an abrupt change in those figures here. And then we're looking at, oil and gas exploration in relation to nesting snow ice. They don't care at all. As long as you're not running over the nest, they can nest right close. In fact, some of them do better nesting close to these areas because fewer people go in. This here has been an issue in the early years. And so Barrow was a place to hunt snowy owls, and people don't hunt them, eat them anymore. It's really rare. But there was still the preponderance to shoot them. And who did it? We can't tell you who's doing it, but we find bodies. And so you kill an adult male or female, and all the whole nest is messed up, and all the chicks die, etc. Unless they're really old and out of the nest, then maybe the surviving adult can feed them. Anyhow, we brought this to the attention up there, and eventually the native village of Barrow passed a resolution, no more killing snowy owls. People come from all over the world to see them. So it ended up good in the end. This was happening over in Russia here. We're not sure exactly what's going on. Purportedly, hundreds of snowy owls were being killed in, wolf or fox traps, and then their eyes sent down somewhere to the Asian market for aphrodisiacs. This was going back to the Stellar's eiders now. I want to talk about kind of a neat bird. I like them. We all like them up there. Their numbers purportedly were declining, and that led to the decision by the Fish and Wildlife Service to kill all the foxes. We don't know how many foxes were killed. I suspect over 1,000 were killed in 10 years. If I'm wrong, sorry, you guys, if you're listening. But this is what was happening with that program. Non-target species were trapped, snowy owls, for example. Traps were placed right on mounds where snowy owls were nesting and or roosting, clearly evident from the pellets and whitewash. We figured this out in the end there, and they're not doing it anymore, but we don't know how many were killed. We just can't seem to get that data. No one will give it up, among other non-target species. But right now it's been resolved. All right, and then some of the other things we're looking at. Why snowy owls evolve sexual color dimorphism? Sure, it makes sense that most of their life is spent in a snow-covered environment, whether they stay in the Arctic in the winter or they move to southern Canada, the northern tier of the US. Yeah, that makes perfect sense. But why are females mottled brown? We think it's for camouflage reasons, and I'll show you here in a moment. And it's very consistent with all open country species of owls. If you look at long-eared owl, short-eared owl, barn owl, burrowing owl, females are all darker than males and have more patterning. Another thing that is interesting is that only white males breed. You have to take that. It takes probably about 4 years or so for them to become predominantly white. Young males that look like females do not breed, do not hold territories in my area. All right. So it appears, and I've got a paper in press right now on this, that females breed with the older white males with resources. It's kind of interesting thing here. This is kind of what it looks like, Those are male and a female. Why have this such distinct sexual color dimorphism? Again, for the females, it makes sense. They're difficult to see on the tundra with this pattern here, but males are bright white like this, almost fluorescent white. And so why be that way? Well, you got 24 hours of light, where most of the other owl species, there's light and dark. And so 24 hours of light during the breeding season. So visual stimulus might be important for female selection of males. And that's what we think is going on, is that females can assess males based on their plumage. He's older, he's got territories. If I breed with him, my chances of securing or raising a family are much greater than these younger males that have nothing. And then the other thing we thought, okay, well, if they're this bright white, do they reflect in the UV range? And so what we've done over the years is we kind of looked into the literature a little bit, and then we've gotten some experts to help us with assessing that. And so what we did, had this guy from NASA, and they had all the right equipment. And so we found one adult male that for some reason was just dead at the nest, and just beautiful adult male. So we just recorded N = 1 in this one here. And it did not reflect in the UV range, but the plumage is super bright, almost as bright as fresh snow. And then definitely it shows its brightest reflectance in certain areas. And that supports, it's in contrast to all other studies, but support one other study a guy did in a museum saying that he couldn't find that they're reflected in the UV range. But it needs much more work. But this kind of shows you here that the UV range, that they're not in, recording the UV range. And then you can just see that their shoulders and their backs, chest, certain areas reflect higher than other areas. Kind of neat stuff. We're trying to put it together, try to get bigger samples for the future here. But anyway, it's all about lemmings and lemming population fluctuations. So what I would say that this is the classic research up in Barrow from 55 to 73 on brown lemmings in particular. And this is where we get this whole cycle idea from Barrow, at least. I don't think it exists. And so is cycle in the strictest definition of the term because of variability in amplitude, variability in timing from year to year. Nonetheless, there's population fluctuation. So when these guys analyze this data, they, this is a high, this was a high, and this was a high. So they said 3 highs, therefore the cycle can peak every 6 years or so. And then others would say, well, why isn't 55 and 56 a high? What about 59? Clearly 64. And so I reviewed every single year in this here and concluded that there were qualitative explanations to say when a cycle should have been, when it wasn't, or when it was, versus really the hardcore data. So we've been doing our own thing here, and it's the same thing. There's definitely population fluctuations, but there's nothing in my mind to indicate that there is a clear predictable cycle. And especially you have varying amplitude, varying years when it peaks. What is a peak? That's a subjective description as well. Nonetheless, the point to bring home here is the trend line for the owls and the lemmings is downward. The owls you can see here more significantly. So the lemmings it's slow, but it only takes 1 year. If you go back to this middle area, all it takes is 1 year to bring that line back up. I keep hoping for that year, but it just hasn't happened since way back in 2008 might have been the last big year. 2014 wasn't bad. Reproduction wasn't very good though. So how are snowy owls doing, population-wise on a world scale here? This is interesting too, So in 2004, the global population was 290,000. 2006, there were 72,000 adults believed in North America. 2009, the global population was estimated 14,000 females, figuring a 50-50 sex ratio, so 28,000 adults using mitochondrial DNA. 2012, someone estimated 78,000 pairs. 2013, 200,000, but 100,000 in North America. 2016, less than 30 pairs. In 2021, 15,000 pairs of individuals. It's hard to say. I have to ask, how do you do this without doing a survey? How do you go from 290,000 to 15,000? And it's all extrapolation, it's all mathematics, but there's clearly no one's out there doing a survey. So these numbers are all over the place. I don't know what to believe. I just don't know what to believe on them until we go out and do surveys. I think these are all just guesses. And this is a little something about Alan Dorff and those guys came up with for using mitochondrial DNA. He basically said you can't do it to look at populations. And I talked to him personally about this. And so anyway, so that may be out of the picture as well. How are we going to do it? Until we, do surveys, are you going to see one individual snowy owl in the vast tundra? And what does that represent? So here's what we need to do. All right, for future tracking. So we have all these snowy owls flying around with satellite transmitters on them. Okay. What we need to do is we need to go to the areas that they breed. All right. And then we have to go back to the areas they vacated. All right, and determine, did they leave because lemming populations are low? Are there any of them breeding? Then we have to go to the new site and we say, okay, how many snowy owls are breeding? What's the lemming populations? Then we have to go back to the previous sites. And that's the only way we're going to figure out if snowy owls are tracking lemmings. And is there one nest or is there 50 nests? So let's just say, someone says, oh, our tracking data indicates that there's a snowy owl breeding in wherever. Well, is there one snowy owl breeding? Is there 50 snowy owls breeding? If we just sit there and make inferences from satellites, we're not going to be able to do this. And another thing too, I believe that if we say, okay, the data indicates that that's a female and she's on the nest, we know that. Well, yeah, if we have to go to court and someone says, for oil and gas exploration, well, did you go verify she was breeding? We say no, but we inferred from the satellite data. We're not going to win. So we got to get back on the ground instead of just sitting in front of screens and making inferences. And this is what I mean by that. So I'm going back to this. So here they nested in Barrow. All right. So then they all left. Right? Now you still have to go to Barrow and see what's around and assess lemmings. Then you've got to go over here to Russia somewhere, or maybe Wrangle Island right here, and say, okay, the satellite transmitter says that they're over there and it looks like they're breeding. Well, you got to go there and figure out if they're breeding. Is there one nest? Is there 50 nests? Are lemming populations high or low? Then the following year, they go over to Banks Island or Victoria Island, Canada over here. You have to go back to Barrow, see what's going on there. Are lemmings still low? Is there any owls there? You have to go back over here to Utqiaġvik up to Wrangle Island. Are there any owls there? What are the lemming populations? And then you have to go assess this. It's the only way we're going to figure out if they're tracking lemmings or not. It's a hard thing to do, but there's harder things to do in life. So anyway, finally, what I would argue is that the snowy owl is without a doubt the avian icon of the Arctic. And even though lemmings might be the most important animal to tell you the health of the environment locally, it's hard to monitor lemmings. They're not very charismatic. people generally don't care. But if the snowy owl is an indication of healthy lemming populations, which clearly it is, then monitoring snowy owls may tell us the health of the local population or the local area where snowy owls breed from time to time. So that's what, and they're easy to survey for. They do it in Alaska every year. They run those waterfowl surveys, and they can tell you, we saw 50 snowy owl nests or 70 snowy owl nests, but we saw 1,000 snowy owls, but no nests, but we saw no snowy owls. So it's doable. Anyway, thanks a lot. I hope, hope I provide some useful information for you guys, and I'll just hang out here until someone tells me to do something.
Thank you, Denver. That was a really great presentation. And we'll start the Q&A now. I want to remind everybody that if you're joining by Zoom, and I've seen several good questions come up in the Zoom chat, and I've recorded them and I'll start reading them.
Should I stop the share screen? Can I take that down?
You might want to leave that up for a minute, because the folks may want to go back in your questions. You may want to go back to a previous slide.
Okay, I hope not.
Yeah, okay. If you're not, so if you're joining by Zoom, continue to ask questions in the chat and I'll record them and ask them aloud. If you are joining by phone, you'll need to raise your hand by pressing *9, and then I'll ask you to ask your question aloud, and then you can unmute yourself by pressing *6. If needed, when things get going, Denver Holt has offered to continue to be available for another 5 to 10 minutes after the top of the hour. So I'll get into the question and answers questions right now. At the beginning of the meeting, Kubajenda asked, with asynchronous hatchings, are the owls that hatch first more likely to survive to breeding age than those that hatch later?
I don't know to breeding age, but owls that hatch first are at least more likely to fledge. After they leave the area, after they fly, it's hard to get information on them. So I can't tell you about, those individuals that we banned after they fledge. And it's super hard to know, but clearly the older ones, will outlive the younger ones if food resources are low.
Thank you. And then I would really appreciate the fact that folks were sharing information with each other. Elizabeth commented that it's such a lovely presentation, such a gift to have been able to spend time with you, Denver. And then Judy Fonsack asked, do both parents feed the young?
Okay, this is getting back what I love, about owls in general, but the snowy owl is a classic example. Males do their thing, females do their thing. There's a division of labor that makes it so simple. So females incubate and brood, males provide food up to a point. All right, so the males bring in the food and they give it to the female. The males do not feed in the nest. All right, then after the chicks leave the nest, it's real interesting. Then the male is almost the sole provider. What he does is he just flies in and he drops off lemmings to the chicks and they gulp them down. The female will do some of that, but she's usually near the chicks, but she's usually sitting off in the distance. And I don't know, you have to make some inferences. Is she just replenishing her reserves because she's been sitting on that nest for 2 months or so? But she's there for nest defense. The male does all the feeding after they leave the nest, or most of it, and he does almost all of the nest defense. The female contributes a little bit on either side of that.
Thanks. And then just as a note, I hope I'm pronouncing your name correctly, Nagaranju Vanganuru from Chennai Institute in India has offered resources with remote sensing applications. So you may want to follow up with that. And
yeah, have an email. You can always chat.
Okay, great.
Thank you.
And Michelle Wrangle says aloha from Hawaii. Great to get this update of your research and legacy of your research. Beth Davidow asks, I had the pleasure of meeting in Denver for a few years ago. He says, is there someone in the Russian Arctic doing similar work on snowy owls? If so, do they find similar results regarding prey, etc.?
Irina Menyushina worked on Wrangle Island for, she must have been there 26, 27 years. And she has retired. I haven't had communication with her, but she really, she's one of the top snow owl researchers in the world. She spent a hell of a lot of time working on them. But since that, I don't think there's been the intense research that she's conducted. You know, she lived on Wrangle Island for months and months at a time, avoiding polar bears and chasing snowy owls around. Now, there are some Russian researchers out there. It's kind of periodic. You know, they capture birds, they put transmitters on them, but you know, this long-term monitoring thing is really pretty rare. But people are trying. You know, there's some long-term research coming out of Violet Island, Canada. I mean, it's young. I don't know how many years I got, 10, 12, 15 years on it now. But yeah, no, in Russia and Scandinavia, it's hard because Russia, it's so vast and it's just hard to find the birds, you know. And then over in Scandinavia, they just don't nest that often. They put a lot of effort into trying to find them, but they don't nest that often. So, you know, there's really hardly any long-term studies, you know, I mean, really. So anyway, it's difficult. It's just, you know, tough terrain.
So the second part of her question was, do you know if the Russian surveyor, the Russian researcher on Wrangle Island found similar results in regarding prey?
Yeah, if I recall, mostly it was lemmings. I can't remember. It's lemmus over there, I believe. But mostly it was, yeah, mostly it was ruled. They were ruled by lemmings primarily, although other species were eaten. Very similar to what I found. I think in most areas, you know, it's all about lemmings, whether it's dicrostonyx, you know, the collar type lemmings that turn white in the winter, or it's lemmus, you know, the brown lemming types. Almost everywhere it's lemmings. In some areas it's half and half, you know, or close to that. Both species are important. But when lemming populations are high, the snowy owls, how they find them, no one knows. How they track these lemmings and find their high densities. And if they find them and they have a good breeding year, we see the results of that during, you know, the following winter or migration. Sometimes we call it an eruption, but that needs to be defined a little bit more. But yeah, it's all about lemmings.
Thank you.
Mhm.
Britt Meyer asks, how unusual is ground nesting and intensive daytime activity as demanded by the Arctic sun in the owl world? And are there any other similar characteristics across the species that share these traits?
Well, I go back to the first part of that and let me just see if I can dissect that so I can give an answer. Can you read that again?
Yeah, you bet. I have to scroll back up. How unusual is ground nesting and intensive daytime activity, she's in parentheses, as demanded by the Arctic sun in the owl world?
All right. They
And
all nest
there,
on the ground.
I'm sorry?
They all nest on the ground, all snowy owls. And maybe they nest on a rock from time to time, but you know, I mean, they all nest on the ground. And daytime activity, you know, we tried to do some budgets on that, and it appeared that when the sun went down and the horizon, you had the long shadows and stuff, they seem to be a little bit more active. You know, whatever, 1, 2, 3 in the morning type of time, long shadows, evening, etc. There was a little bit of laboratory work which kind of, you know, buttressed that they found some, you know, a small sample in captivity that got more active towards the evening hours. But you have 24 hours of light, and then when you have mouths to feed, what we've also seen is that if you've got, you know, 5 or 6 chicks in the nest, the males are pretty much hunting all the time.
I think what the question was asking is, like, in the larger owl world, is the snowy owls ground nesting and intensive daytime activity unusual compared to other owl species?
Okay, then I probably got that totally messed up. Yeah, I mean, it's 24 hours of light, you know, it's the Arctic tundra. Most other species, you know, even though you can have, you know, a varying amount of daylight and night depending on your latitude, but most other species are, you know, nocturnal and nearly so. There are several ground nesting species, even underground, but the snowy owl is quite unique. Yeah, it's 24 hours of light. Like, as far as I can go, I think.
Thanks. Francine asks, how many lemmings are eaten per day by an adult female?
You know, hard to say. We've tried to look at that without really doing an intensive study or something in a lab. We just kind of estimate, you know, that she probably needs, you know, 4 or 5 lemmings a day, and may not, you know, she may not even need that much. You know, she may fast because she probably put a lot of body mass on before egg laying to fast during times of food shortage. So that's kind of what we guess. When we look at pellet analysis, and we look at adult lemming skulls in the pellets versus young, it seems to be that, a 70-gram lemon, you can get, three or so lemmings per pellet, big adults, and maybe they cast a pellet or two a day. So, and it's all guessing on our part.
Thanks. Let's see. Another question is, does the stack of dead lemming bodies attract predators to the nest and other nestlings? Does the stack of dead lemmings?
Yeah, the caches at the nest, it may, the Arctic fox is up there, has a great sense of smell, eats lemmings during the breeding season for them, as well as, shorebird eggs and things, duck eggs. So yeah, they may attract them and may attract polar bears in the coastal areas, but yeah, I don't know, the owls are pretty formidable. And so if a fox comes in, and we've watched them just whack the heck out of the foxes over the years. And fox may occasionally get a chick out there in the tundra, but they may attract them, may attract the weasels, but the owls kill them, they whack the foxes. Polar bears, they can't do anything about it, but they still would hit them. And so we watch them hit caribou when they get too close to the nest. So it may attract predators, but I think the owls are pretty good at defending.
Thanks. Adele Ranking asks, I've heard of sage grouse leks being found in Wyoming using aerial thermal imaging. Would that be a good option to find snowy owl nests? Do population surveys where adults are not fitted to find snowy owl nests / do population surveys where adults are not fitted with transmitters? So I think sage grouse maybe nests being found in Wyoming.
Yeah, I think that's a great option. We kind of have that on our mind. And there's also these like microsatellites too. But I think that would be great if, one of you guys want to come up with the technology and help us out, run some transects. I think it would be great. There was a guy here in Montana who had a drone, and he ran this drone around here, and he called me one day. He says, hey, I'm getting these thermal images, and, they're big thermal images. And I went out there, and there was a bunch of snowy owls wintering this field that was kind of remote that nobody knew about. So I think that that's got potential. And I think, drones, these kind of microsatellites, we were trying to figure out if you could do it by satellite, but it would be great if we could do it. It would just help because the Arctic tundra is so vast. Yeah, help us out. Sponsor them. All right.
Good. Beth Dividow asks, with the Arctic warming and getting more rainy and tundra more wet, do you have any feelings based on your work how these changes might affect the owls?
Yeah, I think that we're clearly seeing that up there in the Arctic. We sometimes are reluctant to admit it, but we are clearly seeing some wet summers, happening here. The ice pack is changing, all that stuff. What we're trying to do, and it's beyond my skills right now, is and I've been complaining about it for several years, is we really need a high-powered statistician to come in and take the weather data from Barrow and compare that with a lot of the results that we have as far as nest distribution, lemmings, and all that stuff there. So I think there's something to be said about that. It's just having the time and the expertise to do it, and that that requires a professional, not a hobbyist or someone like me who has okay statistical skills but not great.
Thanks. Michelle Wrangle Regula asks, what is the youngest age an owl can be banded?
The snowy owl chicks, again, I'm sticking with snowies here. We try to band them just prior to leaving the nest. Their legs are big enough at that time. So we try to get them, 18, 19 days. They leave the nest right around, 3 weeks of age. Occasionally we'll miss one, and then we'll have to find it on the tundra after it leaves on foot. But right around there, we try to get them all marked before they leave.
Thanks. Francine asks, regarding migration, what is the trigger that makes birds head south? Do the sparrow snowy owls migrate to Montana or stay mostly in the east? How far south do they migrate each year?
Yeah, well, I think in birds in general, there's they're innately programmed, a lot of them, to migrate. So, and that's what we see with these young birds, is we see, especially in a good breeding year, we see this, these eruptions, and the eruptions are almost all, most of a high percentage of them are young of the year. So I think we forget that sometimes, that they're programmed to migrate. And how far south do they go, I think might have been part of that. You can go from Seattle to Boston, across the southern Canada, the northern tier of the US. Occasionally a snowy owl will show up further south. They've shown up in Florida, Texas, Northern California. There's that one a few years ago that showed up in Hawaii, probably rode a ship over there. And then there was those past few years ago, about 5 or 6 of them joined a ship from the east coast of the US and ended up departing when they got to Spain, stuff like that. So, and was there more to that question? I didn't catch it all.
I think that was it. Let me read it again. Just how far south do they migrate?
Yeah. And I don't forget that, like many birds, they migrate, and it's not this thing that, oh my gosh, they're all starving, I mean, that's been, not to some time, that's been disproved years and years and years ago, that a lot of these snowy owls, they migrate and they live and they go back to the tundra and they come back the next year to their wintering areas.
Thanks. Matt Lilly asks, are lemming populations so closely tied to other Arctic animals in addition to the snowy owls?
Yeah, in our study area, I can speak best from that. It's snowy owls, lemming and lemmings. It's Palmer and Jaegers are tied into it. And what we see is, and I go back to what I'm saying about an indicator of the health of the local environment. In Barrow, I'll just read it off. Snowy owls, Arctic fox, both species of weasels, glaucous gulls, I think sandhill cranes as well. I said the fox, and just about everything up there that's, a carnivore, let's just say, we'll consider the gulls that for the moment, is tied into lemmings and have a better breeding season when lemmings have high populations and when lemmings have low. And the other thing, which is super interesting too, is that when lemmings have a high population, the shorebirds do better, the ducks do better, because the predation on them and their nests and eggs and chicks is lessened because there's so many lemmings around, and lemmings are easier to capture. So the lemming is a great indicator of the local health of the environment, but some people think the lemon is citrus fruit, so you got to study the snowy owl.
Thanks. We'll allow folks to stay on that can, but I want to do a soft close on today's webinar, and then we'll get back to questions, because generously you offered to stay on for another 5 to 10 minutes. So for those who want to continue discussion, we'll stay on after I do this soft close. And for those leaving now, we want to thank you for joining us today and extend a special thanks to Denver Holt for such a great presentation. Today's webinar will be archived and available on the ARCIS Seminar Series webpage at arcis.org. An email containing a link to that page will be sent once the video recording has been posted. You can also visit ARCIS homepage for more information about ARCIS, our programs, and upcoming related events. We continually work to improve our seminar series, and we look for suggestions for future West seminar topics and speakers. Please do take a minute or two to complete our short survey. A link to that is available now in the chat window, I believe, and or it will be soon. It'll also be sent in the email to everyone after the webinar is archived, and that will be at surveymonkey.com, and please use that. We also invite you to join an upcoming webinar on Wednesday, the 11th of May at 9 a.m. Tobias Ashore from the University of Alaska Fairbanks will present on harnessing the power of community science to address data gaps in Arctic observing. Registration for that event will be online soon. So we thank you all for joining. Please do take advantage of filling out that survey, and we look forward to communicating with you in the future. Okay, back to the questions then. And let me just make sure that I've got in the right spot. I think we are down at Matt Lilly asked again, is permafrost thaw a concern for snowy owl nests?
Yeah, I don't know that. Yeah, I don't know that. I always thought that the active layer, which is the layer that melts in the summertime, has been increasing. There are some people who say that, but I've talked to other people, friends of mine, researchers up there, that say the active layer is not increasing, but the tundra is sinking. So I don't know how it affects snowy owls, they do like the drier sites, so maybe it'll benefit them. I don't know. And maybe they can dig deeper holes. I don't know how the heck they do it when it's frozen that time of the year, but I don't know the answer.
Thanks. And Britt Meyer, to clarify the question she asked earlier, says, is ground nesting common with other owl species besides the snowy owl?
Yeah, short-eared owls, we study them here in Montana. Short-eared owls nest on the ground. Burrowing owls nest underground. And then there's some grass owls over in Africa, and maybe some over in Australia that also nest on the ground. So it's not super common, but 268 or so species of owls in the world, and only a handful of them nest on the ground and underground, like the burrowing owl.
Thank you. Gilles Gauthier asks, snowy owl research on Bylot Island in Canada has been going on also for the past 25 years. Our results confirm many of those presented by Denver today, which is good to know. And John Sonnen says, thanks Denver and Arcus for today's webinar. Dorothea Eric asks, the lemmings on Wrangle Island are, and I need help with the pronunciation of it, is it Crossonix vinogradivy?
Okay.
And Limus trimu.
Yeah.
Okay, breeding of snowy owls follow the lemming cycle there too, like elsewhere in the Arctic. What is unique on Wrangle is that some snowy owls nest almost every year. This may be due to the fact that lemming cycles are different and low years not that low, possibly because there are no small mustelids on Wrangle Island. At least this was like that before presently ongoing climate-related changes in the ecosystem. This was from what Irina told, is it mentioning?
Menushina.
Yeah. Thank you, told me.
Yeah. Yeah, I did just to say that we have snowy owls in Barrow every single year too. And they don't always breed though. So we can have pairs of snowy owls sit on territories and for a period of time before they decide, just to leave. So we're unique in that respect as well. There's always snowy owls here, but they don't always breed. I've heard where people say the female snowy owls breed every year, but that's not in our site.
Thank you. And then Judy Fonstach asks, do you have current ongoing research on snowy owls? If so, what are you looking at?
Yeah, well, continuing the monitoring. I think that's the important thing. Continue the monitoring of the lemmings and the snowy owls. There's other little things you can do, but I'm the little short-term things, but there's behavioral stuff that we could do. But I think the most important thing is to monitor the owls and the lemmings over time. I've got 30 years of data from the one site, which isn't bad, but not great. If I could get another 10 years out of it, I'd be happy. But I think that's the most important thing, is to monitor them. And then, there's little graduate type studies you could probably have someone do in between, but the important thing is the long-term monitoring.
Thank you. And there are a ton of accolades and thank yous to you in the chat. I won't read through all of those, but just acknowledge that folks really enjoyed your presentation. And
hopefully it was all right.
That's great. But I don't see any other questions. Are there questions that are coming up? Do people want to raise their hand if they're on the phone? I see no further questions. I'm looking around, making sure that I'm catching anybody whose hand might be up and don't see any. So with that, Denver, did you want to add any concluding remarks based on the kinds of questions?
No, we're just, yeah, basically with long-term research is key, and the same researcher conducting the same studies, adjusting and learning as they go, I think is the key to, your solid data. And so that's what we do.
Thank you.
Thank you very much.
Well, then I think we are ready to close. And again, on behalf of Arcus, I want to thank everyone who's joined us today, and a special thanks to Denver Holt for his excellent presentation. One more time, today's webinar will be archived and available on the Arcus seminar series page. You can also visit the Arcus homepage for more information about Arcus and our programs and upcoming Arcus related events. Again, we always continue to look for ways to improve our series, and suggestions for future seminar topics and speakers, please do take a minute to complete our short survey, and the link was provided by Kuba and is again provided in the chat right now. That link will be provided in the follow-up email sent to everybody once the seminar archive has been posted. So thank you again to our speaker, Denver Holt, as well as everyone here for joining us. Some really great conversations going on in chat. Really appreciate the networking efforts that people have made. And this concludes our webinar. Wishing you all well and have a great day.